Okay, I'm going to go through the problem we did in class the other day where we had the CD that was spinning. So make sure y'all can see. Okay. Okay, so we had an audio CD and it's spinning. And the information they gave us was that it's got a diameter of 120 millimeters. So we know we don't like that. And it spins at 540 revolutions per minute. So every minute it goes around 540 times. This is the same as a frequency. Remember, frequency is your number of revolutions or cycles or some kind of periodic motion per time interval. So when you see something over time like this, that tells you this is a frequency. Okay. And so things we wanted to know about this CD. Okay, we want to know the period. That's our capital T. Remember, period is the inverse of frequency. So period is 1 over frequency. Frequency is 1 over period. And period is the time it takes to complete a revolution or cycle or whatever. So we want to know the period. We have a little speck of dust out here on the outer edge of the CD, and we want to know the velocity of it as the CD is spinning. And then we didn't do this in class, but I'm going to go ahead and calculate the centripetal acceleration as well of the CD. Okay. So before we start, we need to do some conversions because we always want to be in meters, we always want to be in seconds, we always want to be in kilograms. That's not here, but you always want to go back to those base units, and we can see that we got a couple of these that are not in our base units. So the first thing we'll do is convert our diameter from millimeters to meters. So there's 1,000 millimeters in 1 meter. That's going to give me 0.12 meters. That's my diameter. And with circular motion, we really want to deal with radius because that's what's included in our equations. So we're going to divide that in half. So let's just see what that is real quick. 0.06. And that's what we'll use in our calculations. And then we also want to convert this frequency into revolutions per second. So we're going to have 540. Oops. I'm in trouble getting all this in one place where y'all can see all of it. Okay. 540 revolutions per minute. We know that in 1 minute we have 60 seconds. So we're going to divide 540 by 60. That gives me 9. So I have 9 revolutions per second. That is my frequency. Okay. Okay, so my first step is period. How can I get that? So remember that period is 1 over frequency. And I know I just converted this, so I know my frequency is 9 revolutions per second. So I'm going to have 1 over 9 revolutions per second. So when I divide this out, these units are going to flip. It's like dividing by a fraction, more or less. So I'm going to end up with seconds on the top. And that's going to give me 0.111 forever and ever. 0.11 seconds. So that's my period. So it takes 0.11 seconds for the CD to spin around 1 revolution. So 1 takes 0.11 seconds. All right, then velocity. We have a couple of equations that we can use for velocity. We can use 2 pi r over t, so that's my circumference, which is my distance or displacement, divided by the time it takes to travel that distance, which is period, or I can use 2 pi r times frequency, since frequency and period are the inverse of each other. I kind of like the 2 pi r f because that way I don't have to divide. It doesn't really matter. You can use either one, okay? So I'm going to do 2 times pi times 0.06 is my radius, times 9 is my frequency. So let's calculate that out. 2 times, gotta find pi on my calculator, times 0.06 times 9. And that gives me about 3.4 meters per second. So that's how fast my little speck of dust is spinning as it travels around and around and around the edge of that CD. Okay. All right, and then my last step, like I said, I didn't do this in class because we hadn't really gotten to this equation yet, but I'm going to add it in here. My centripetal acceleration is v squared over r. And I have everything I need to do that. So I'm just going to plug in 3.4. I got to square that. And I'm going to divide by 0.06. That's my radius. So I've got 3.4 squared divided by 0.06 equals 193 meters per second per second. That's pretty big number. But it's spinning at a pretty fast rate. I mean, it's completing 9 revolutions every second. So it's got a, I don't know. I don't really know any comparative numbers here, but that's the number that we get. This number is pretty small. Okay, so you see some relationship here between radius and centripetal acceleration. Okay, so that's just the example we did in class the other day, plus added centripetal acceleration calculation.